Welcome back to part 6 of this first and third person player controller course. Last time we looked at slope handling, step handling, wall physics, and wall glitching. In this part, we'll be doing a bunch of finishing touches, including polishing our jump mechanic, adding in third person controls like camera zooming, and adding actions and animation layers such as attacking or a gathering mechanic. Let's get it going in 3, 2, 1, 1.5, 1 3/4. Alright, so we're back in the project, and as you can see here, there is a problem with our jumping animations. When we are turned left or right and we jump, our jump animation faces forward instead of the direction that we're currently facing. So let's go into the animator and fix this. We got to make a blend tree for our jump and falling animations now. So first create a new blend tree for jump up, and we're just going to copy in the exact same transition parameters for our current jump animation. Then do that exact same thing for the falling animation, make a blend tree for it, copy in those parameters, and then we can go ahead and delete our old animations. For our jump up blend tree, we use the 2D freeform directional blend type like usual, and input X and input Y as our parameters. Then add in 4 new motions. Now we need our normal jump up motion, which we can drag in, but then we also need a jump right or a jump left. So let me just show you a little trick here. Copy the jump animation, paste it into our folder, rename it, and open it up in the animation tab. We can actually really easily just rotate this animation by about 45 degrees. Select that jump up right animation, then find the root q.y parameter and click on curves instead of dope sheet at the bottom. Now if you zoom in, you'll find all of the keyframes. We can select all of these and just move them up until we've rotated roughly by 45 degrees. Then just save that and go back into our blend tree. So I'm gonna go ahead and drag in jump up again so that we have 2, then drag in the jump up right twice as well. For our normal jump up, we want the positions to be at both 0, 0 and 0, 1. So we use that animation when we're standing in place and running forward. For the jump right, we put that at 0.707 and 0.707 again. Then for jump left, we click on the mirror box and just set those same corresponding values. So I'm gonna fast forward the next part, but we just go through this exact same process for our falling blend tree. I don't think it's worth talking through, but all the steps are playing sped up in case you need them. So in play mode, it actually looks like things aren't working yet. That's because we need to set our input target's value correctly when we're in the jumping state. Go into your player animation script, and this is a little confusing, but basically we need to set the correct values for whatever our blend tree's maximum value is. It turns out our jump, falling, and run blend trees all go to the same max value. So I'll create a new bool here named isRunBlendValue, which is true if we are running, jumping, or falling. I also think at this point, the logic is hard-coded a little bit too much, so I'm gonna go ahead and create a member variable to keep track of our blend trees. So our sprint max blend value is gonna be 1.5, run is gonna be 1.0, and walk is 0.5. Now we can just replace our hard-coded values down below. Okay, back in play mode, you can now see things are working. Our jump and falling motions look much more natural for our movement direction. There is one tiny issue though, which is when we jump completely sideways, like 90 degrees to the left or right, we're rotating to the 45-degree animation when really I think we should be just returning to the 0-degree animation. So a quick fix for this is just to go back into our blend trees, create 2 motions in the jumping and falling blend trees, and we're gonna put those at -1, 0 and 1, 0, then just drag in our default jump and fall animations. So now as you can see, things are looking really good. I think this is as far as I'm going to take our jump animations, but before we move on, there is one tiny bit of code I want to add to our player controller class, which is a terminal velocity. We don't want to infinitely accelerate if we just start falling down. We want to cap out that value, so I'll make a float named terminal velocity. Then in handle vertical movement, we cap the vertical speed by saying if vertical velocity is greater than terminal velocity, then we set it equal to terminal velocity. I also want to control for negative numbers here, so throw a mathf.absolute in front of each of those parameters. And in Unity, let's try a terminal velocity of 50, and just a quick check in play mode shows that if we drop our player from a really high height, we don't reach a ridiculous velocity, and all our collider detection still seems to work properly. Okay, so now we're going to add in input controls, but only for our third person character. This is actually a really important step that we do correctly. So the goal is to have a modular architecture so we don't need to include unnecessary code for our other first-person controller. That means that we should create an entirely new script for our third-person input and decentralize our player input so that we have some kind of input manager managing all of our input scripts. So let's create an input folder under our scripts. I'm going to move our locomotion input in there, then create a new script named player input manager. I'm also going to create an input manager game object, and we can just add the player input manager script to it. Open up the input manager script, add the namespace at the top and the default execution order so it runs first. Then we're going to make this a singleton. That means we need a public static instance of the class name. Instead of initializing our player controls in our locomotion input class, we're now going to initialize it here. So I create this public player controls property. In awake, we make our typical singleton pattern, so only one can exist at a time. In the onEnable function, we'll initialize and enable our player controls like we've done before. Then similarly, in disable, we disable our input. Now over in player locomotion input, we no longer need player controls. That's because player locomotion input is only going to worry about our locomotion action map, so delete the player controls and the other calls to it, and instead we'll just get a reference to our action map by using our new class player input manager.instance. We should also put in some kind of guard check here to make sure our player controls is initialized. So we write if player input manager.instant ? And okay, so what does this question mark do? Well, it's called the null conditional operator, so it will only try to check what's after it if it's not null. So if our instance is not null, then it checks if player controls is null. If either our instance or player controls is null, then we print out this error. So I'll go ahead and paste this into the onDisable method as well. And just to demonstrate this, let me actually change the execution order so that this script runs first. In Unity, I try to press play and we actually get 2 errors. So our debug message comes through saying that we haven't initialized our player controls yet. We expect that, but we also get this error because when we try to use the player controls just in the lines below, we get a null error. So we got to fix that. Back in the script, all we need to do is just return if this condition is true so that the below code doesn't run. I'm also just going to switch back the execution order so things run properly. Okay, so we've set up our manager. Now let's create a new input script for our third-person actions. Make a script named third-person input. Now we want to attach this script to our third-person controller and not our first-person controller. So now you can see how we've modularized our input. Before we open up the script, let's create an action map. Open our player controls, create a new action map, and name it third-person map. I'm just going to add in one action for now named scroll camera. And for this to work, we need the value action type and vector2 control type. Then for the binding, we want to bind our scroll wheel on the mouse. So this will let us zoom in and out from our character. Save that, and you'll notice that we don't have any errors right now when usually in the past we have. That's because our player locomotion script only cares about our locomotion actions. So we've actually kind of decentralized our input in this way that's really nice. Let's go ahead and open up the third-person input script and get to work. So we can actually just copy our player locomotion input script because it's going to look really similar. Change the class name back, then change the interface to our third-person map actions and delete all the properties at the top. Next, we need to enable our third-person map instead, so switch all of those over, and then we can delete our update method for now and all of our input callbacks. Now we just got to go to the top of the class and implement our interface to get the on-scroll camera function. So we only want to change our zoom if we've performed an action, otherwise we return. Then to get our scroll input, we just need to set it equal to the context.readValue vector2. Let's print out this value to see what we get. All right, in play mode, when I scroll, we either get this positive 120 or negative 120, depending on which direction I'm scrolling. I find it easier to just work with a normalized value here, so let's head back into the script and make some small adjustments. First, let's make a property to store our scroll input. So you can see it here. I just didn't type it live, so add that in, and then at the bottom of the class, we'll set our scroll input equal to our local variable .normalized. But I want to have a setting to control for what speed that we zoom in. So back at the top of the class, let's make a serialized float named camera zoom speed. Then we'll multiply scroll input by the camera zoom speed, and finally multiply also by a -1 to make it go the correct direction. We can also add another serialized field named camera min zoom, and then I'll add one more named camera max zoom so that we limit our zoom range. Then one more serialized field. This is going to be of type Cinemachine virtual camera. We're going to need this because this is how we'll actually control the zoom distance. Also, let me just add some underscores to these guys real quick. Okay, great. So we actually need one more thing, and that's going to be the Cinemachine third person follow. I promise this is all going to make a lot more sense in just a sec. So initialize this in awake, and then let's create an update function real quick. So on update, we want to change the camera zoom. So what we do is set the third person follow camera distance to plus equals the scroll input dot y. Then we're going to clamp this value to the min and max zoom. And actually, it's probably a bit more efficient to just operate once on the camera distance. So just copy this function up here. And the very last thing is let's reset our scroll value in late update back to 0. Cool, so I know that was a lot at a time, but let's set this all up in Unity now. First, drag your virtual camera into your third person input script. We can set some initial values like 0.1, 1, and 5. And actually, I found that 0.2 worked a little bit better for me for the zoom speed. And now in play mode, you can see that I'm zooming in and out by scrolling the scroll wheel. This is really awesome because not only do we have a nice convenient spot for all of our third person controls, but we've also modularized our project in a way that the first person controller doesn't need to use it at all. Unfortunately, there's still quite a bit of work to do because we've introduced a bunch of bugs here. Click on your virtual camera, then go down to the composer. Now in play mode, things might seem fine, but if we scroll out a little bit and zoom out, sometimes objects seem to be blocking the view of our player. And if we rotate down beneath our player, it's like we're looking through the ground from underneath. And this is bad. We really don't want this behavior. So what's the best way to fix this? Luckily, Cinemachine has us covered. You'll see there's an obstacles header and a camera collision filter setting. If we set this to default, now our camera will actually collide with objects in the scene, and we won't be able to go through them. In the game view, now you can see that if we rotate beneath our player, we're actually just kind of sliding along the ground and getting closer and closer. And really, this is much better in how most games work in this scenario. Again, against walls, we kind of wrap around the wall a little bit instead of phase through it. And unfortunately, as you can see, there's kind of an additional bug that we've introduced here, which is basically that our camera is flipping back and forth. So this happens because it's trying to look at a certain target, but it's no longer able to when it's colliding against the wall. So it decides that flipping around will actually give you a better view of it. So we absolutely do not want this. And actually, if you remember way back at the beginning, we set our max view angle to 70 degrees to prevent this. If we set it back to something like 89, you can actually just see without the wall, we're flipping back and forth again. So can we just outright prevent this from happening even when we use 89 degrees? Luckily, yes, we can. Change the aim from composer to same as follow target. I really wish that I had done this originally because I think this is a much better setting for the third person camera. In play mode, we no longer get this flipping effect, even when we push up against a wall. Now I will say, it seems like we're looking a little too high now, so I'm gonna adjust this. We can actually just move the dummy camera down and everything still works fine. So just adjust that to the position that you think looks best. Back in play mode, I'm thinking things are looking pretty good at this point, but let me show you another small adjustment that we can make. So if I move up against the wall, you'll see that the camera shifts pretty abruptly. We can make it lerp smoother by changing the damping into collision rate. But I did try out like 0.3, and I do feel like this gives a better, smoother feel. But you know, probably depends on what type of game that you're making, what you set this to. Some people might just prefer 0. All right, so that actually is it for third-person camera controls. Obviously, you can add in more special bindings for camera control if you want, but I'm gonna leave that up to you guys. All right, so I really wasn't sure about adding this part, but you know what, we've made it this far, so why not? We're gonna add in some player actions like attacking and gathering. This will be a very coarse setup. I just wanna show you the ropes and some really cool results that you can get using animation layers and avatar masks. It would probably be better if I made a state machine for all of these actions, but for now, I'm just not gonna bother. Head into player controls and create a new map named player action map. I'll add in 2 actions, one named attack, which I'll set to left mouse click, and then another to gather, which I'm just gonna make the key E. Go ahead and save that. And next, let's create a new script named player input actions. We're gonna do a very similar thing here. Copy one of our other input scripts to get started, change the class name and the interface for the actions, and then we can clear out the properties and startup methods. Let's also make sure to swap out the action map, so you're gonna wanna switch all of these to player action map. Just doing a little bit more cleanup here, and now let's implement our interface. which gets us our 2 input callbacks, on attack and on gather. I'm going to create 2 properties at the top named attack pressed and gather pressed. Then inside each of the callback functions, we return if we aren't performing the action, otherwise we set our new booleans to true. Let's make a late update function where we reset these values to false and at the end of the frame. Okay, so head into the editor, open up the animator and go to the top of our player animation. This has been a long time coming, but we finally see why I made this locomotion a substate machine. The reason is because we're going to create a new substate machine for all of our actions now, and I'll just name it actions. Okay, so let's grab a couple animations. From our imported blink asset, there's a gathering animation and a punch right animation. We'll go ahead and drag those into our own animation folder. Drag those animations on into the animator, then we can make a transition into gathering. We need to add some new parameters though, so make 2 booleans named isGathering and isAttacking. For the transitions, just make sure each one is set to true for each animation, then we'll make a transition that automatically exits these states. For the transitions out, for now I'll just set it to next state, but we're actually going to come back and change this later on. For the transitions in, make sure you uncheck can transition to self and set interruption source to next state. Okay, and now we got to go back to our animation script. Set up your new hashes named isAttacking hash and isGathering hash, and you know what? I'll go ahead and organize this a little bit because there are a lot of hashes at this point. Now we just got to set the values from our animator, so set bool for isAttacking, and actually we need a reference to our player input actions. So at the top of the class, let's just get an instance real quick. Okay, and now we can just set them each to our actions.attackPressed and gatherPressed. All right, let's try this out. First, make sure your player actions input is attached to your third-person controller. Okay, in play mode, unfortunately nothing is happening. So in the animator, you can actually see that we're just continuously firing this transition back into player locomotion. So let's check out these transitions actually. Basically, if we're grounded and we're not idling, then we're going to be transitioning in, which is exactly what's happening when we begin an action. We aren't in idling. So we need to solve this. I'm going to make a parameter named isPlayingAction. Now for each transition into locomotion, we'll make sure we add the condition isPlayingAction is false. So just to make sure that this works, we can check isPlayingAction to true real quick. And yep, now you can see that I'm playing the punching animation correctly. So let's go ahead and code this up now. We create our new hash for isPlayingAction, but I'm also going to create something new here. We'll make an integer array named action hashes, which will store all of the hashes that count as an action. In Awake, we can initialize our action hashes array with all of our actions, like isGathering and isAttacking. How can we easily set isPlayingAction to true if any of these actions are currently playing? Well, we're going to take advantage of a lambda function here. So basically how this reads is for all of the action hashes, we get the Boolean value of that hash and check its value. If any of them are true, then we return true through this lambda function. So a lot is going on in this lambda function, but this is the perfect use case for one. Finally, let's go ahead and set that value in the animator afterwards. And okay, awesome. Our gathering animation is now playing correctly and not getting interrupted by idle, but as you can see, it's just playing over and over. This is a bit of a frustrating problem. We need to set the Boolean value to false when the animation is done playing, but what is the best way to do that? Well, we could do something like get the length of the animation in the code, write a coroutine, and set it to false at the end of the coroutine. But there's another way to do this, which I would argue is the more, quote, unity way of doing things. So we can actually trigger an action at the end of an animation. Unfortunately, to do this, we need our animations to be editable, which they currently aren't. So in the animation tab, if I select gathering, you can see that it's telling me it's read only in the top left, and I can't change anything about it. The reason for this is it's part of an FBX file, but it's really actually pretty easy to get a workaround. So find the animation in your animations folder, copy it and paste it, and now it's a standalone animation that can be edited. I'm also going to move the old gathering animation file out of this folder because we don't need it anymore, and then let's quickly do the same for our punch right animation. This is really important. Make sure you go into the animator and replace the animations with our new ones, otherwise this will not work. After replacing those, we can go back to the animation tab and select our gathering animation. What we're gonna do is go to the last frame, then add in an event at the top here. Over in the inspector, you can select a function to call from this action. Let's quickly head into player actions input and create a function. It's going to be really simple. Just name it public void set gather pressed false, and then we just do the same thing. We're going to do set attack pressed false as well. Back in the editor, let's find the animation event, click on player actions input, and call the set gather pressed false function. Then let's also make sure to do the same for our attack animation. There's one more thing that we need to change as well. Back in our animator for our exit transitions, we need to make sure the interruption source is actually set to none. Otherwise, it's possible that the last frame of our animation doesn't actually run, and then our function would never get called. All right, so now testing this out, you can see that we're gathering, then we transition back into idling finally. Oh, and I can feel it. Can you? Incoming bug report. Yep, we have a bug. If we start moving while we gather, then it looks like we continue playing the gathering animation and slide around. So this brings up a new topic actually. Are these actions supposed to be interruptible or uninterruptible? Of course, this is up to the game dev, but to me, something like gathering should be interruptible. That is, the animation stops playing and the action stops happening when you start moving. But attacking with a punch, I kind of want that to be uninterruptible actually. And if possible, it would be nice if we could sort of combine both the attack animation and whatever movement animation that we're doing. So let's go ahead and get working on that. Inside our player actions input, we'll just make a call to player locomotion input. But first, we need to get an instance of it, so I'll just do that real quick at the top. Then we're going to say if movement input is not vector 2.0, then we set gather pressed and attack pressed to false. Also, we want to cancel our action if we're jumping or falling, so let's also get a reference to our player state. Then, in our if statement, we can also say or current player movement state is falling, or current player movement state is jumping. So basically, if we try to move while we're playing one of these animations, it'll just cancel, and you can see that right here. Inside play mode, you can now see even if I move a little bit, it cancels our gathering animation, and same thing happens when we jump. So currently, we can't punch and we move at the same time, and I don't think that's the behavior that I want, but also we can't just play the punch animation while we're moving, otherwise it's going to look like we're sliding around again. Well, Unity has a way for us to take care of this problem actually, and it's called animator layers. So the first thing that we're going to do is delete the set to false line here so we no longer cancel. And now in play mode, you can see it no longer cancels, but we get this weird sliding that I was talking about. So go into the animator and we're going to create a new layer named upper body. Now I'm naming this upper body because basically we're going to override our locomotion animation with our attack animation, but only the upper body portion of the animation. Quickly go back to the base layer, delete that punch animation, and then in our upper body layer, drag in your punch animation. But then I'm actually going to create a dummy null state for entry because I don't want to play our punch animation immediately. So just make sure the default animation is set to that one instead of punch. And then next we can define a transition into punch right, set the interruption source to next state, and make sure our conditions are set for is attacking is true. Then we'll make a transition out of the state to exit. And this next part is the crucial part for getting this to all work. In the layer options, you can see there's something called an avatar mask that's currently empty. So let's go ahead and create an avatar mask by right-clicking, select create, then find avatar mask. I'm going to name this one upper body. Okay, so expand the humanoid section and you can basically see that we have different parts here highlighted in green. Now you can see from our attack animation, we really do need both arms, the head, the neck, and the torso to be part of the attack animation for it to look good. So in our avatar mask, let's just disable the legs and the foot IK. The last thing that we need to do is turn up the weight value, and we want to set this all the way up to 1 so that we completely override our base layer, then choose our upper body avatar mask. You can now see our upper body layer has an M next to it, denoting it's an avatar masking layer. Oh, and I did forget to set can transition to self off, so do that real quick and then let's press play. This is honestly so amazing. We now have our punching animation working while idling or while running, sprinting, whatever locomotion state that we have. Our upper body portion of the punch animation is actually overriding our locomotion, and the result honestly looks really good. There is one little slight bug here causing us not to transition back into the locomotion state. So go into the player animation class and make sure to take out the isAttacking hash from our actions. So really, you should think of this array of actions as the interruptible actions only. So in our base layer, I'm just going to denote that these are interruptible or cancelable actions here. Okay, and so I'll do a little showcase here, but everything is now done. Our attack animation works with our locomotion no matter what state we're in, and honestly, it looks pretty good overall. I'm impressed with how well these animations are blending together. Man, this was a huge part again, but super important. We made a modular architecture so that you can basically just add an infinite amount of player actions and choose whether they're interruptible or uninterruptible. Also, at this point, all the big features are in place, but there will be one more part just to really close things out and iron out a few kinks. So if you made it this far, congrats, you're basically done. Make sure to like this video if you found it helpful, and I'll see you in the next one. Peace!